Now we're going to go on and look at picturing data. I mean, frequency distributions and stem and leaf plots do help you get the data organized. And a stem and leaf plot does sort of give you a picture of the data if you turn the graph sideways. So I talked about that. But if we could come up with a way to organize data into some kind of a picture like what you see here about the hate crimes, then it just really at a glance gives you a sense of what's been going on. Okay, so like with this one, this graph was made to give you a sense of what was happening from 2005 to 2020. So what you have are the number of hate crimes reported for each year from 2005 to 2020. So what they did is they made a graph. Across the bottom, they really should label things, but I guess that was obvious, so they felt like they didn't need to. Across the bottom, we have the year, and on the side, we have the number of hate crimes. Now here's where if the number of hate crimes were kind of big, they might say in thousands or something like that, or in millions if that were the case. But here they just actually put the had the axis be the vertical axis was just listed 1,000 hate crimes, 2,000 hate crimes, and so on. And then all you do is you plot each of these pieces of information. So 2005 was a little more than 7,000. So think of a dot being right there. 2006, 7,722. Now look, down at the bottom, they went from 2005 to 2007. So 2006 would have to be right there, halfway in between. 2007 was a little less, so you see that slight drop. 2008 was back up, and it was a little bit higher than 2006. So you just kind of do your best. If you're doing it by hand, you do your best to estimate where those points would be, and you keep that up until you get all the points plotted, and then they basically just connect them, right, to create this picture. And then once they connect them, then they shade underneath, because that just kind of allows you to focus on the trend that you see happening there. And so looking at that, just with a glance, you can see there was a drop from around 2008, so that's like right here. Let me do it in a different color. A drop from like 2008. You know, I know there's a little up and down, but until, you know, let me get rid of that so I'm not biased. So from about here, it was a high point and then kind of went to a low point there. I know there's a little up and down, but basically it's dropping. And then in around 2014, it starts increasing in after 2014, and it's now up to, you know, a new high. So it basically allows you to kind of see the trends in the data at a glance rather than looking at a chart and looking at the actual numbers and trying to see, wait, where did it go up? Where did it go down? You can just see it in a glance. So there's two that we're going to talk about next, where we have data. We're going to look at data that's categorical, meaning we have categories and we know we've kind of tallied and we know the frequency for each of these, okay? So bar graphs and pie charts or circle graphs are ones we can use to illustrate the data here. So let's do a pie chart or a pie graph. So what you do is you're going to take that information and you're going to think about a circle. And in a circle, all the way around would be 360 degrees. So think about a circle kind of like a clock. This will help you a little bit get these things placed. And just think about how you have hands, you know, the 1 o'clock, 2 o'clock, 3 o'clock, all the way around. So each of these little sections would be split into 3. And each of these little pieces right here would represent 30 degrees, because there's 12, right, all the way around on a clock. There'd be 12 of those, and 360 divided by 12 would be, actually, divided by 12 wouldn't be 30 degrees, would it? Yes, it would be 30 degrees, okay? And then the other thing you do is you go over to your data. It's already been tallied up, and you add it all up, And in this case, when we add, we get 100. Now that won't always happen when you do a frequency table, but it did here. And then what you need to do before you do your pie graph is you need to see what percent that was out of the whole. So you do it by taking 10 divided by 100, which would be 0.1, and then converting it to a percent, which would be 10%. Now each of these, because the total was 100, 39 out of 100 really is 39%. 19 out of 100 really is 19%. And then we have 32%. So what we're going to have to do, and I'm going to go back to this first one and give myself a little more room, is I'm going to have to find out what part of the circle that would mean I need to shade. So I need to do 10% of 360 degrees, and if I did, 10% of 360 would be 36 degrees. 0.10 times 360 would be 36 degrees. So we're going to do that for all of it. I'm going to do 39% of 360 degrees, and that would tell me how many degrees I need. That would be 140.4 degrees about. 19% would be about 68.4. I don't know if it's about or exactly. So I'm just going to do a squiggle, and that would be 68.4. So to do that, I'm taking 0.19 times 360. I'll show that on the bottom one. To do 32% of 360 degrees, I typed in 0.32 times 360, and it turned out to be 115.2 degrees. Okay, so now what I'm going to do is I'm going to come over here, and I like to think about that clock. Okay, so I'm going to clean it up a little bit in here, but I'm still kind of thinking about those quadrant. Oh, let me just start over. Okay, so I'm going to think about that circle. I'm going to think about it's hard to draw because I have to write vertically. Okay, I have to think about that, and I know that each section of the circle, so when I had it broken into 12 pieces, each section was 30. So that means 36 degrees, if I thought about this broken into 3, would be a little more than one whole. It would be 6 degrees more than that. So I would wind up maybe going about right there. Okay, these are hard to draw accurately by hand. Okay, now I'm going to change colors, and I'm going to do never. So never was 39% of the circle, which was supposed to be 140.4 degrees. So one whole quadrant would be 90 degrees. And then I need to get to 140, so I need about another 50.4 beyond that. So I'm kind of thinking about, as I'm coming around here, so this was 36 right here, remember? So then, let me change to a different color. So then 140.4, so 36 would mean I still have out of that about 24. So 36, 6 more. So I have about 24 here. And then this would be another 30, so that would be 54, okay? Because that would be 24 left in that one, and then 30 here. These are hard to draw by hand, so you're not going to really be drawing them by hand. I just want to give you a sense of how you would do it. If I added a full 90 to that, which would be this, that would get me to 144. So I need to just be a little short of that, just about 4 degrees short of here. So I'm just going to maybe draw it about right there. Okay, and this would be that category. And then 68.4, okay, so I think about where that would be, okay, and I come in and draw that one, so that would be 68.4, so that would be about 2 of the sections and a little bit more, so now I'm just kind of roughing it, okay, so maybe like that, and then I need 115, so I need 90 degrees plus another 25, so I need one more color. Let me see if I can go in here and add another color. Add a pen. Let's make it orange. And this category I could shade. Then they should all turn out filling in the whole thing. So let me clean it up a little bit. And then the last thing you would do is you would label. So this right here would be always. Okay. This right here would be never. And you would have like a little legend that would tell people, you know, what it was. So you could label it like this as you go around, like I'm doing. Okay, and here's occasionally. Or what you could do is you can color code. So you can say frequently is green, okay, and then always was blue. And this one was kind of fuchsia colored. And then occasionally was my new pen, my orange. Okay, you can do stuff like that. All right, so these you typically, if you did try to draw it by hand, you'd almost need a protractor to get it to be fairly accurate. So you typically would just use Excel and let it draw that for you. Okay, and it also helps sometimes to remind people what the percent was. So like never, you would say was 39%. Frequently, you would write those over here to make it easier for people. So you've already seen pie charts that look like that, okay? And so this is kind of the idea. If you were trying to create one yourself, this is how they get created. So always was 10% and occasionally was 32%, okay? So, of course, if I wanted to, I would do that larger and clean it up, but I'm just trying to give you a sense of how they do it. So a pie chart is used to compare different parts to a whole, but a bar graph is better when you're comparing one part to other parts, okay? So for instance, here is that same marketing firm, but this time they surveyed 100 grocery shoppers, but they asked them, which grocery stores have you shopped at in the last month? Okay. So when you look at this one, notice if I were to add that up, I'm going to get a more than 100. Okay. So that's one of the reasons, since they surveyed 100 people, but people could answer more than one thing. Okay. So would a pie chart make sense? The answer would be no. Shoppers could select more than one store. Okay, so when that kind of thing happens, a pie chart's really not appropriate. Okay. And then down here, let me do the bar graph. Okay, so your bar graph is basically going to have two axes like that. And what you would do, these are still categories. So let me turn it sideways so I can write. So you might have Publix, and then Trader Joe's, and then a bar for Fairway. Never heard of that one. Okay, this is rough. You can look at my completed notes to see a better picture. Aldi, and then other. And then you would choose a scale to use. And so typically want to start at 0 and then go to your highest one is 65. And think about how to draw the axes so that you can get 65 up there, but also so you can figure out how to separate things. So I decided to go to 80, even though that seems strange, because then I know halfway is 40. I like to cut things in half. This would be 20. This would be 60. And then I can get an estimate of my bar, because I know then I don't have to label them, but all these in-betweens would give me the 10, the 30, and so on. So Publix had 50. So I would draw a bar that would go up to 50. And then for Trader Joe's, I would draw a bar that goes to 40. Okay. And for Fairway, it would go to 28. So I have to go just slightly less. So I'm kind of thinking about 30 would be there, and I want to be slightly less than that. Typically, you would have these be evenly spaced across the axis because it would just look better that way. And then 33 would be a little more than 30, okay? And then other was 65, so that's going to be, if that's 60, that's 70, 65 would be halfway between those two, and I would make my bar hit that height. Okay, so you can look at a better one or imagine doing a better one. where the bars are more, straight and even. But that's the gist of drawing a vertical bar graph. Now, bar graphs can sometimes be drawn horizontally, and they're sort of like histograms in some respect. But what they do is they allow you, again, at a picture to see that Publix and Trader Joe's are very popular. Okay. And you can kind of get a sense of people's shopping habits in the area. All right, now we're going to work on trying to just interpret some graphs that have already been drawn for us, because these are pretty complicated graphs. So a lot of times people think bar graphs are just a piece of cake to interpret, but if you look at some of the more complicated styles, this one includes a lot of information here. So what we have here, if you look at it, is a survey that Kaiser Family Foundation did about their intentions with regard to the COVID-19 vaccine. And then these were summarized, okay? And what they wound up doing is putting the information into a kind of a horizontal bar graph, you could think of it, where you had over on the side, you see June, May, April, March, right? Starting from December 20th, January, February, March, April, May, June, okay? And then the different colors tell you how many people had already gotten the vaccine, how many were going to get it as soon as possible, how many were going to wait and see, how many would do it only if required, and how many would definitely not. And it says to describe trends among those who had already been vaccinated. So already been vaccinated. So that would be this one, which would be that first one, the kind of light green. And what we notice is that in December, nobody had already been vaccinated, but a lot were as soon as possible. But then you can see we had 6%, then we had 6%, and then 18%, and then 32%. And you see how as we went, 56%, then 62%, and then 65%. So more and more people. Upward trend, right? Upward trend. More and more people were getting vaccinated. So the percentage of people getting vaccinated was increasing. And you can even tell where the greatest jump happened. You see that right there? Okay. That greatest jump happened between March and April. Now it's been a while. So I kind of forget when we first found out about it and all of that. But I'm sure that was we could maybe look at advertising campaigns and things and how information got disseminated and what people learned about it and so on. All right, now the other question they're asking us that we can answer by just looking at the graph is this one. This says, which category was most stable from December to June? December to June, so from here to here. Which category seemed to remain most stable? So if you look at it, that seems to be this category, okay, which is only if required, and maybe that one's pretty stable too. That one fluctuates just from, let's see, what was that number? 13 to 15%, and this one fluctuates from like 6 to 9. So both of those are pretty stable, okay? So the only if and the definitely not categories seem to be fairly stable. And our conclusion there might be that these people probably had thought about it and already made a decision about their feelings about it, and they probably decided early on, and nobody was going to convince them otherwise. So I'm just going to jot that. Probably these respondents, people who responded to the survey, these respondents had decided early on. Against getting vaccinated. And no one could convince them otherwise. All right, but that bar graph is a kind of a complicated one that had a lot going on, but it's just a different style. That one was a horizontal bar graph that contained a lot of information, right? Now here's another type, time series graphs. All right, that's kind of like the hate crime one earlier, was pretty much a time series graph. So if you have data that's been collected over a period of time, if you use a time series graph, that just gives you a sense of what's been happening to whatever you were collecting information on. So here we have another one that's a crime-related one. So here it was saying that politicians often talk about violent crime in the U.S. in apocalyptic terms, but let's look at the data. So they looked at the number of violent crimes committed per 100,000 citizens every 5 years from 1980 to 2020, and our job was to draw a time series graph for the data. All right, I kind of think of these almost like line graphs. Sometimes they're called other things, but so what we would do is we would have one axis that we would use to show the violent crimes. Okay, and I would probably write it this way: violent crimes. And these were per 100,000. So you would tell people that, so you didn't have to write, instead of this, you didn't want to have to write 596,600 people. So you would just say per 100,000 over here. And then across the bottom is where I could put the time. So I might have my 1980. And then keep having my little tick marks for the years. Okay, depending on space, I think I can get, I need to go all the way to 2020. So let me see. I better not, let's see, if I do 1990 and then 2000, go every 10 years, 10. Oh, I could stretch that out a little more. All right. So if I did 1990 there, and then go here for 2000, and then here for 2010, and then another 2 for 2020. Pretend those are perfectly evenly spaced. I did a better job on my completed notes than I'm able to do drawing it this way. Then when I look at these numbers, I see a low of this, but of around 400, and I see a high that goes to 729.6. So I might go to, say, 800, and then half. I like to do things I can cut in half, and that's 400, that's 200, this would be 600, and then I can start plotting that. So 1980 is just barely below 600, so I might put a dot right there. Okay, 1985, which would be this middle spot, that would be at 556, so 500 would be there, so it'd be like about right there, right? And these tick marks should be evenly spaced so that as I plot things, I'm only going to plot one more, and then you can see the gist of it. And that would be 700, so 729 would be a little above that. And then you connect them, okay? You think about connecting them like that. And you just go along, and once you get it all done, I'm just going to now kind of show, you can see how it drops after that every single year. So then you go, and at the end there, 2020, it's a little less than 400. Okay, so a little below 400. So it kind of just, you'd have all these other drops, but it kind of drops until you get to 2015, and then it goes back up just a little bit. Okay, so something like that. All right, and you can look at my completed notes to see a better graph, but then it allows you to look at it and discuss the trend. So the violent crimes per 100,000 citizens were decreasing from 2000 from what was that 19 from a high of 729,600 in 1990 until it was decreasing until 2015 with a slight uptick in 2020. So we can kind of see that at a glance. And this one, I think you could argue, you could tell from the data as well.